All right, let's go. Okay, so if you have questions, just drop them in the chat and we'll answer them. So inheritance and object-oriented programming. We're gonna have 3 sections. First is variables, which I'll do, then Todd will do inheritance, then Abhishek will finish with dynamic method selection. So just kind of a preview of what we're going through. Okay, so variables. So for this, there will kind of be 3 different sections that I do. So first, it'll be like primitive versus reference types, then static versus instance variables, then just a discussion on scope. So let's start with primitive types versus reference types. So just recall in Java, different from Python, every variable which you declare must have a declared type. So like if I want to declare an integer, I have to say that it's type int, right? I have to write like int number when I declare it. And so that type, that declared type, is what we're referring to when we talk about primitive and reference types. So primitive types are the 8 most basic types which come with the Java language. So a type is just a data type. It's just telling you what type that data is, and it helps you identify exactly what the data is. And so there's 8 specific primitive types in Java: bytes, shorts, ints, longs, floats, doubles, booleans, and characters. You're probably most accustomed to like using characters, ints, and probably doubles, but these are the 8 most, and booleans. These are the 8 most basic types. And then everything which isn't one of those 8 types is a reference type. So when you're asking like, is this a primitive type or is it a reference type? First you check, is it one of these 8 types? If it is, that means it's a primitive type. Otherwise, the reference type. So what exactly is a reference type? The idea is that reference types store references to objects. So like, for example, in the project, when we made singly linked lists, an SL list, like if you declare that type, the SL list, is a reference type because you're referring to a singly linked list object. And within reference types, there's 4 specific reference types. So just like within primitive types, there's 8 specific subcategories. Within reference types, there's 4 specific subcategories: classes, interfaces, arrays, and type variables. So hopefully you're familiar with the first 3. A type variable is just referring to something like a generic type, which you also saw in the project. So let's just do some examples to kind of drive the idea home. Let's take like 3 minutes. For each of these, write down whether or not it's a primitive or whether it's a primitive or reference type, and then as a challenge, which specific subcategory of primitive or reference type are they? So let's take like 3 minutes.
Depends.
Okay, that is 3 minutes. So let's just use chat. So we'll just go through them one by one, and you can just put the answer into chat. I figure that's easier than like someone saying it out loud. Okay, so let's start off with int 5 equals 5. So is this a primitive or a reference type? And specifically, which subcategory of those is it? All right, so people seem to say it's primitive and it's an int. Yeah, that one's hopefully straightforward. In order to tell whether or not it's primitive or reference type, first we ask, is it one of the 8 basic primitive types? It is, it's an int, so it's primitive type, and then specifically it's an int. Pretty straightforward stuff. Okay, then how about this one? Byte b equals 123. Okay, yeah, so primitive byte. This one is very similar. You just check to see that it's a primitive type by seeing that a byte is one of the 8 primitive types, and then just by the declaration, we can tell that it's a byte. Okay, and then for the SL list, a single linked list, which we've defined with just a new SL list. So, okay, so it looks like, yeah, so reference type, and I guess there's some confusion on what subcategory it is, but probably class. Yeah, so the 5 in SL list just means that that's the value that I'm initializing it with. Nothing more than that, yeah. But okay, yeah. So this is a reference type, and yeah, it's a class type. So if we go back, because maybe people are confused about this, the 4 reference types are classes, interfaces, arrays, and type variables. Classes are just like the objects that you define. Interfaces are the things that the classes will implement, or almost like an API that the classes will implement. Arrays, hopefully you're familiar with those, and just like defining an array. And then types are those like generic, like type variables, so like the generic types that we learned. Okay, and then D, so we define an integer array called R, which is these 4 elements. So which primitive, or is it reference primitive? Yeah, so it's a reference type and it's an array. And then E, Boolean cat equals false. Primitive, yeah, so yeah, right. So primitive Boolean, again, you just check to see if it's primitive type or Boolean type. It is one of the 8 primitive types, and so yeah, and then you can tell the type because it's just a Boolean. Okay, and then F, which is a Boolean array of cats. Yeah, so this is a reference array. It doesn't matter that, it doesn't matter that they're made up of primitive types, that like each individual element is a primitive type. It's this overall like array type that we're focusing on. And then lastly, T item. Yeah, so that's a reference type. And does anyone know the specific subcategory? Oh, I see what you're saying. So like it's a reference and then it's also a type variable. Yeah, so this is a reference variable we know because it's not one of our 8 most basic primitive variables, and then all right, most basic primitive types, and then that we know it's generic. Yeah, because we know because it's generic that it's a type variable. All right, so then the next topic, static versus instance variables. So these are just kind of some like basic definitions for each. So instance variables, you define them inside classes. So kind of like I've defined inside this class pineapple, this int slices, but not inside methods. So they're variables that are defined in classes, but not inside methods. And each object, like when you make an object of a class, so a specific copy of that class, it has its own version of that instance variable. So like you could have multiple pineapple objects, and this slices value could be like different for all of them. But with static variables, these are also declared inside classes and not inside methods, just like instance variables, except they have this static keyword. And this static keyword just means that every object in this class shares this variable. So in this case, like different pineapple objects could have a different amount of slices, but they would all have the same value for whether or not, like they would all have the same value, either true or false for their Boolean is spiky. Okay. So, right, so they're both declared within classes. For instance methods, oh yeah, okay, so this is static versus instance methods. That was static versus variables. This is methods specifically. Both of these are declared within a class, of course. Instance methods are specifically make it so that the object has to be created or instantiated before the instance method can be called. and the method is called on that specific object, not like on all the objects. So for example, you use like this keyword to refer to this specific object. Whereas static methods use the static keywords. You could see like this uses a static keyword, and it can be called without creating any objects of the class. So I don't have to create any pineapple objects, and I would be able to call this is spiky method, and it would it would work. But if I don't create a pineapple object, then I can't call num slices, because I can only call num slices on a specific object, specific instance of the class. Yeah, no, so you can't call static methods on this. Or if you tried, I think, actually, not exactly sure. I mean, oh yeah, I think if you just do that, it will just return the general static like definition, like the general shared variable that all of them have.
Yeah, to jump in real quick. So static methods are shared by all instances, which means all instances also have access to the static method. So calling this dot the static method is equivalent to just calling the static method, because it's not that not that it doesn't belong to any instance class, it's just shared by all the instances of a class, if that makes sense.
Okay. So just to make it like a little bit more clear, there's this nice table. So just some rules for static and instance methods. So for instance methods, you can access instance variables and methods. And you can also access class variables and methods. This is just like static variables and methods. Static methods can also access other static variables and other static methods, but they can't access other instance variables and other instance methods. So essentially, it's yes for everything, except specifically static methods cannot access instance variables and instance methods. And that makes sense because static methods are shared by every single object, every single instance of that class. And so they wouldn't be able to access the variables of a specific instance of the object, of the class. Okay, so let's do a practice problem here too. And so let's just, going back to 61A, so hopefully you remember how to draw environment diagrams. Let's just draw out the environment diagram for this class, and specifically what's going on in the main method here. And so I've provided the definitions of like what's going on in the class up here. And then specifically a question I want you to think about after you've kind of drawn the environment diagram out is, what if this line here instead said like type equals 5, for example. So yeah, so draw out the environment diagram, and then kind of a bonus question to consider is this. So let's do 3 minutes for this also. Okay, that's been 3 minutes. So I think it's not super easy to like interact with what the environment diagram should look like. I'll just walk through it. But I do want to ask someone this question that I posed here. So like, what do you think would happen if, instead of this line, this method change variable instead set type to 5? You could put it in the chat, or you're right. So it would error, but okay, yeah. And so specifically, why would there be an error? Why would there be a compiler? Why would it refuse to compile? Right, because static methods can't access instance variables. So you can see that type is an instance variable. And because of that, since changeMaterial is a static method, it is not able to edit type. So anytime that rule is broken, there will be a compiler error and your program won't compile. But let's just walk through the environment diagram. So the first line of main is creating this stone object, which just has this instance variable called type, which has value 12. Right? We define that through the constructor. And if you need a reference of what main looks like, it's up here. Also remember that this is initialized to true. So we have this Boolean earth material, the static Boolean earth material is initialized to true. And notice it's a static field. So the next line, space rock. Same thing, you're defining a rock object. This time it just has a different value for the type. But now that we have these, I want you to consider and can just put this in the chat. If I called stone.type, what would I get? And if I called spacerock.type, what would I get? Right, so, okay, so yeah, so 12 and 349. So because type is an instance variable of the rock class, it would be object specific. So it would look at stone, this specific object, and look at its type, which is 12, and return that. And then when you call this, it would look at the space rock object specifically and return its own version of the variable, which is 349. All right. And then the next line of main, change material to false. This basically just changes the static Boolean earth material to false. So now what would happen if I called stone.earthMaterial and spacerock.earthMaterial? What would those like return? What are those values? Yeah, so yeah, so both these would be false because earth material is a static field. It's a static Boolean that every single instance of the class, so every single object shares. And it's now been set to false, which is why the value is false. And then lastly, the last line of main, we do stone.changeMaterial to true. So we're using stones. So this is kind of the question that someone asked before, but we're using stone specific instance, right? Or not specific instance, but we're calling change material from the stone object, and we're giving it true, which should set earth material to true. So then now what would happen? I guess we kind of already answered this, but both of these would just return true because it's static variable, right? So they both share the same version of the variable. So yeah, so this is kind of what someone was asking before. So hopefully that's more clear now. Okay. So then the last topic for variables will be scope. And so the scope is just this idea that there's a region in your Java code where a certain variable that like you pick out a certain variable, there's a region where it's considered to be defined and where it can be accessed. So you can only access a variable within its scope. So that again, that's just the region that it was created. So for example, if we want to do something like increment some integer pineapple by 5, Java has to figure out where pineapple is, right? It has to figure out, are we in pineapple's scope? So it has to search the scope to figure out where pineapple is so that it can actually edit pineapple. So it does this in this exact order. First, it checks the local scope, which is the current method body, and I'll go through examples. Then the current instance scope, which are the attributes of that specific object. And then it checks classes that this class inherits from. So this is called inheritance, and Todd's going to cover it. But I'll cover the first two. So first we start with local scope. And local scope, again, is just the current method body. So if I look at this method do magic, right? the current method body is the stuff between the brackets. So if I look within the brackets, this is like a scope. This is a local scope right here. So a question to pose to everyone, you could just answer it in the chat, is assuming I call getMagic, so this function, which magic variable gets changed by this bolded line? So I call getMagic, right, which calls doMagic, and then that does something to this magic variable. But which specific magic variable is changing? Like, is it this one, or is it this one, or is it this one? Right, the local version. So yeah, the one inside doMagic. And so the reason for that is because first, we just check the local scope, right? So we just check within these brackets, is there another magic? And so the easy way to do this is just start at, whatever you're considering, like whatever thing you're trying to do, and then work backwards until you reach a bracket and look for that variable. And so in this case, we find it here. And the important thing to note is that this doesn't change the variable up here. So even though we fed this Boolean magic and getMagic into doMagic, it only changed the local variable. So it only changed this local variable magic, even though this value technically came from this method. So you have to be careful because Java is passed by value, right? So that's where scope is important, because if you want to change this value, then you should return instead, and then use that up here. Okay, and then current instance scope. So current instance scope is just the instance attributes of the object which we're, the instance attributes of the object with which we're currently in. So this is just pretty straightforward. You just look at the instance variables. So in this case, it's just this Boolean suite. So so for example, like if we're in this eat candy function, we have some if statement and it's altering some variable suite. So we get to this line, so Java has to go and look for suite. First, it checks the local scope, so it'll work backwards up until it hits this bracket, and it'll be like, okay, I didn't find a variable suite. So there's nothing in the local scope. So then it proceeds to the current instance scope, and it looks for the instance attribute. It looks at the instance variables, and it sees that there is a suite here. So when we set suite to be false or suite to be true, we're specifically editing this suite, this variable here. And so then what happens when there's nothing in the local scope and there's nothing in the current instance scope? Then we get to the concept of inheritance, which is what Todd's going to talk about.
Sorry, I'm just getting my stuff set up. Give me 1 second. Cool. Perfect. Can everybody see that? Cool. Okay. And then oh, that works too, right? Awesome. Okay. Yeah. Anyway, thank you all for coming. We're a bit short on time, so sorry if a lot of this seems pretty rushed. We're going to try our best to get through everything because we have a lot to cover, as Anjali said. So let's talk about inheritance, right? Inheritance refers to classes and subclasses, and also in this class, we kind of use it to refer to interfaces too, although we'll use a different keyword. But in general, all of these topics are basically just ways of managing complexity of a program, right? Or basically ways of organizing like all of our classes so that, our programmer doesn't have to maybe write a lot of code, or like we're able to reuse code, or maybe like organize, I don't know, create some hierarchy. Yeah, just all the reasons and motivations behind this. I know specifically we didn't touch on the keyword extends until about today, at least not too much. But yeah, we'll still talk about it a little today. But anyway, so classes and subclasses, right? Let's say I have like an animal class, right? We're going to say like, and then let's say I have like other animals that I want to implement, right? So a way I can organize this is I can have like maybe a dog and cat class, right? These dog and cat classes will what we call extend another class. Or you can say that dog is a child's class of animal, or maybe animal is a superclass or a parent class of dog. Again, these are all like really big words, tons of vocabulary, right? But just just like just ways of saying that these are related. Okay. The rule is that each class can only extend one other class, or I can only have one parent as a dog, basically. As like a corgi, I can only have one direct parent, right? Dog's parent is animal, corgi's parent is dog, right? There's no way we can do something like this, where I say like, oh, corgi is also a parent of, I don't know, bird, right? That's not possible. This is illegal in Java. So remember, each class can only extend one other class, or each class can only have one parent. However, you can say that multiple classes can have the same parent, right? Or a dog class can be extended to both a corgi and like a Shiba Inu or something like that. Yeah, I'm going to be moving on, but feel free to drop any questions in the chat. Okay. We also talk a lot about interfaces, and I think interfaces will be a little more in scope for this exam. So interfaces are another way of managing complexity. Interfaces are implemented by classes. You can think of interfaces as Sai said, like kind of an API, if you know what that is. If you don't worry about it. Interfaces are basically a set of methods that the class has to define. This helps us manage complexity by saying, oh, if I know cat implements like both the 9 lives interface and the feline interface, then as a programmer, right, I can just directly use these feline interface methods, right, in cat without worrying about the actual kind of implementation itself. And that's kind of the idea behind your project 1 interface too. Interfaces can also define something called default methods, which we'll talk about in a second. And the rule is that, remember, classes can implement multiple interfaces, as you see here. But remember, classes can only extend one other class. Hopefully that's pretty clear. Again, short on time, so we're going to be moving on. Let's talk a little bit about like overloading versus overriding too. And sorry if this seems like a lot of lecture. We're going to be setting up, like this is all the buildup to something called dynamic method selection, which Abhishek will be covering in a second. So please just like bear with us for a lot of this buildup. But yeah, so overloading versus overriding, right? Overloading is when you have 2 different methods that taken in the same class that have different input parameters. So for instance, this bark right here and this bark right here are an example of overloading. You can see that these 2 barks are within the corgi class, right? But one of them takes in no arguments and one of them takes in an integer n, right? And to a programmer, that means I can actually use either of these, right? Depending on what functionality I want for my bark. So that's what overloading is. Overriding is used in class hierarchies or interface hierarchies. Technically, interfaces don't have a hierarchy, but like mainly class hierarchies. It's when a subclass shares the same exact method signature. And we'll talk a little bit more about which one to pick during something called dynamic method selection. But in essence, like you can see that these 2, so I have a class dog and I have a corgi that's a subclass of dog, okay? The class dog has a bark method, the corgi also has a bark method, right? So we say formally that the corgi class's bark method overrides the dog's bark method. We'll be talking about overriding a lot. Hopefully there's no questions, but is that clear to everybody? Okay, cool. So let's just do some like very, I don't want to say basic practice, but let's just do some sanity checks here before we get into dynamic method selection. So I'm going to be walking through these questions actually one by one. So we'll do like about 30 seconds a question. But everybody, it'd be great if y'all could familiarize yourselves with the code on the left. Give everybody about a minute to just read out. So we have like a dog class, we have an interface, and then we have a corgi class that both extends the dog and implements the interface. Cool. Okay, so does anybody want to tell me what the first line says? So first of all, we have a corgi called Jake and a dog called Milton. Okay. So if I do like jake.bark, notice that these types are the same. that'll become apparent or important in dynamic method selection. But either way, what does Jake.bark like print out? Yep, prints out a root. How did we find that? Well, we know Jake is a corgi, right? So again, as Saya mentioned, the rule is that when we're like looking up a method, right, in terms of scope, we look first in the actual class, and then we look inside like the class's methods. In this case, we found this bark, and it prints however you pronounce that. Okay. By that same logic, what does Jake.eat kind of produce? It produces yay. Okay. Now, same thing with our scope argument. First, we check that we know Jake is of type corgi, right? And corgi kind of, or our class corgi is down here, right? But corgi does not have an eat method, right? So the rule is if we look in the class and we don't find a method, generally, in most cases, we will look in the parent class, right? I say in most cases because dynamic method selection may change things. But in this case, yes, we're looking in the parent class. In this case, we have an eat function or eat method in dog, right? That corgi inherits from dog, so this prints yay. What about Jake.loudbark? Woof, yep, exactly. So what ends up happening is Jake is a corgi, right? We look in here, we see that there's no loud bark. So we actually check both the class and the interface, right? The interface has so yes, exactly, good question. Superclasses are checked first, right? We check the dog class first for a loud bark method. There is no loud bark method here. So then we start checking the interfaces, okay? So now, since corgi only implements one interface, we check rowdy dog, right? Rowdy dog has a default method, right? What default means is that if I have not implemented this method anywhere, right? You see that dog doesn't have a loud bark, corgi also doesn't have a loud bark, then we're going to use that method. So we have the woof, right? We'll be talking about dynamic method selection in a second. That's its whole own category of method selection. But yes, in this case, what about Jake.angrybark? Rar, yep. So this case is a direct case, right? We look in the corgi class first, and we see that it has this bark, this angry bark method. Cool. What about Milton.bark? Yep. So again, in this case, Milton is a dog, right? So the rule is we check the dog class. We see that there's a bark method, right? This is the bark method, and boom, it's lowercase wolf. Cool. What about Milton.loudbark? This one's kind of tricky. Error. Okay, all of y'all are saying error. In general, we like to specify, at least in this class, whether it's a compile time or runtime error. I'm just going to say right now, outright, that it's a compile time error, and we're going to learn why in a second when we talk about dynamic method selection. Yeah. But any questions on just how the method lookup works? Like this is just an extension of scope, right? So just to review, right? When we're looking for a method, we first look in the actual class. So if I say like Jake.loudbark, we look in the actual class. Then we look in the parent class or parent classes, right? So if dog had another parent, we would first check corgi, then dog. Then let's say if I said class dog extends animal, we would then check animal, okay? And then after that, we check the interfaces, right? In particular, we need the default methods of the interfaces. But yeah, any questions there before we move on to dynamic method selection? Classes come first, then we check interfaces. Although we'll be emphasizing interfaces a lot more this exam.
To be clear, in the exam, we will never ask you a question where there is both an interface and a class that has a function, and I expect you to know which one comes first. DMS in this way that we test on in this class is almost entirely restricted to superclasses and subclasses because that's easier. Don't worry too much about what comes first when there's multiple interfaces or any of that business. We're not going to test you on that.
Thanks, Anjali. But yeah, those are all the questions. I think y'all did great. Out of the interest of time, let's move on to dynamic method selection. So that'll be Abhishek.
Hey everyone, so let me just share my screen. Hey, can everyone see it? Yeah, so Tal and Sai have been doing a really good job at building some infrastructure on how variables work and how they relate to each other. And now we're going to talk about dynamic method selection, which is how does Java actually pick which methods to run. Yeah. So before we get into the actual process, there's some groundwork we need to build. And the first thing is clarifying the difference between static and dynamic typing. So a static type is the variable that we see on the left here in this example. So we dog here. And this is what we declare the variable as, and this is how Java will see it in the compiler. The next thing is dynamic typing. And this is what we see here. This is Corgi. And this is typically what specifically what Java will use during runtime. And Corgi can, or sorry, this dynamic typing can only be a subclass or the same class as the static typing. So this could be dog, or this can be a subclass of dog, but can't be any paired class of dog. And this is what we're using in runtime, and this is what we're using during compile time, just to clarify that. So I'm gonna start off with a quick question. So read over this little bit of code and try to figure out which one of these would cause an error. So I'll give you guys like a minute or two to do that. Okay, yeah. So the error would be number 2. And that's because we can't have a subclass be the static typing and the dynamic class be the parent type. So now, next thing we talk about is the actual procedure itself. And it can kind of be broken down into these couple steps. So the first step is that we're going to figure out what the static class is of the calling object or the function, or like, sorry, the variable, and any of its parameters. So now we make sure that everything works, and we make sure that the signature, the method signature, or whatever function we're using is in the static class. And at that point, we lock onto that method. So I'm going to talk about a little bit more about locking onto methods once we get to examples. But basically, Java's going to be saying, okay, I have this method in the static class, and I'm going to run this. And that's what's thinking during compile time. So as soon as we enter runtime, we're going to let the dynamic class. So we would look at Corgi in the example from before. We see if the same method with the same signature is overridden. And in that case, we're going to lock onto the method in the dynamic class. And finally, we're just going to run whatever method we locked onto. This is going to seem a little intimidating. So I have an example here. So going through the steps I just listed before, let's see. Let's figure out what method will be locked onto. So like 1, 2, or 3 during compiler time and runtime. So I'm gonna get started. So can people say in chat what will be the compiler method for snoopy.e? And what about the runtime method? Yeah, so exactly. So walking through this step by step, snoopy.e, we're gonna look at first the static typing. So we see dog. So we go to our dog method, and we find eat here. So we're gonna lock onto eat. And now, in case we don't find anything in the dynamic class, we're gonna stay with eat and we'll use this method. So now we're in runtime, right? We have this method locked onto. We're gonna go to dog, and it turns out since these are the same class, we can just go back to this method and we'll return 1 again. What about the compile time method for Jake.e and the runtime? Okay, so you guys are doing great. So really similar to last time, since this is Jake is dog, what we'll do is we're gonna lock on to this method. And we're gonna stay here during compile time. But once we go to runtime, we see that Jake's a hungry dog. So we see in hungry dog is there a method with the same method signature that's being overridden. And we see that this is here. So we put runtime as 3. Okay, what about blue.e? And what about during runtime? Okay, perfect. So you guys got it. We look at hungry dog and we lock onto this method here. And really similar to what we did in snoopy.e, since they're the same class, we see that we're gonna be using the same method in compile time and runtime. So I made up this figure here just to make it a little bit clearer in case anyone's still confused about how dynamic method selection works. So the first question we ask ourselves is this method defined in the static class? And if it isn't, if we don't see it, then we have a compile time error. Otherwise, we're gonna lock onto it here. And now we go here and we see is the method overridden in the dynamic class? And if it is, we're gonna pick the dynamic version. And if not, we'll pick the static version. And this is really the heart of dynamic method selection. And if you ever get it on any midterm, you can usually refer to this diagram and you should be able to get the solution. Yeah. So for this, just gonna chat, you only get runtime errors with this. At least not with dynamic method selection. I might be wrong, but usually you'll find a compile time error. If anything. Yeah. So the rest of this is really going to be built around doing practice, since I think this can be a little confusing, but in theory, but I think after doing a bunch of practice questions, people will kind of get gist of it. So similarly, what with Java display, and like this, we know dog a equals new dog won't produce anything. So if you see that, just say nothing. Yeah, I'll give everyone a couple minutes to do this. Just a quick note, like Anji said in chat, please ask questions. This can be a bit of a confusing subject, and a lot of students usually have trouble with this. So don't feel afraid to ask questions. I think if you're thinking it, I'm sure that other people in this research are also thinking it. Okay, so I'm gonna get started here. So you knew that when we ran this line, Java won't display anything. There won't be any errors here. And same thing for this line, because we talked about this example before. But what about this next line? Yep, the compiler time error, because we see that this is the static type is not, or static type is a child of the dynamic type, and that causes an error. What about the next line? Yeah, okay, so nothing would happen here. This is a perfectly fine line. But and now what about a dot e? Oh yeah, so print eating, really similar to what we did before. We lock onto this method during the compiler time, and we go to the runtime. We see that they're the same static and dynamic type, so we can just use this method. What about a dot eat dog food? Yep, you guys are spot on. This is gonna be eating dog food because we see that we're gonna lock onto this method, really similar to before. And then during runtime, we'll use the same method because it's dog and dog. And what about d.eat? Yeah, so this one's to be eating a lot. Really similar. Once again, these are more warm-up questions. So I'm glad you guys are doing well. But yeah, it's gonna be locking onto this method during compiler time, and then running the same method during the runtime. Okay, so here's some more questions. So let's take a couple minutes to solve these. All right, so I'm gonna get started. So can someone tell me what happens if we do d.eat or just put in chat? Yeah, so it's gonna be doing eating a lot. And that's because it locks onto this method during compiler time, and it'll lock onto it during dynamic because they're the same class here. What about, oh sorry, you would b.eat, but what would b.eat be? Yeah. So that's because so we see we have dog here, and we lock onto it here. So that's during compiler time, right? But now we see that our dynamic type is a hungry dog. And when we see that, we're gonna go to hungry dog. We see the method is overridden, so we're gonna use this one. What about b.eat dog food? Okay, yeah, you guys are doing great. So we go here and we see b's type dog. So now we go here, we see there is a method here with the same signature that we need. So we're gonna lock onto this method. We get a runtime, we get a hungry dog, we see the method isn't there anymore. So we can't run it. Or we can't run anything from hungry dog, so we're gonna use this method that we locked onto previously during compiler time. What about a.part? Yeah, so this is gonna be compiler time error. Oh, I don't know why that happened. This is gonna be compiler time error because we see that bark isn't here. And same thing for b.bark because once again, we go to dog, we see that bark isn't here. So I think these were questions that came up in chat. If we can't find it in the static type, we're gonna return a compiler type error. And lastly, what happens if we do d.bark? Yep. So we get bark, and that's because it locks onto this method, row 74. And then we see the same thing in runtime. And so that's all I had. I have an extra slide here with a video done by one of our TAs. It's about like 15-20 minutes long. So if you guys are still confused, I would really recommend watching this video. I think it explains it really clearly. Yeah, there's no questions. So I think so. If I'm not sure I answer the first question.
I think the question is basically if dog was an interface, if I'm reading it correctly, rather than a class, and hungry dog implemented the dog interface. I'm assuming that you intend for dog to be have default functions as well. I guess the question is, would it return the same thing? I'm not sure if that'll impact it. Oh, it might. Yes, that would still have a compile time error because the general idea is that the static type would still not have a function that is bark, right? It still doesn't have that function written anywhere inside of it. Even if the interface doesn't implement the function within the interface, it knows that any class that implements that interface does. So normally that would be allowed, but there's no bark within the dog interface, and so that would still have a compile time error, if that clears that up. I hope I answered the correct question there.
I mean, next question is, so runtime error, I think Todd, Anjali have been a really good job in chat trying to explain it. So you don't really get those with dynamic method selection. You get those more so when you're providing logic that will cause an error. So I think Anjali did a really good example of explaining like divide by 0. So the compiler won't pick up on that. If you have like 2 ints that are divided by 0, it will just return an int during compiler time because it hasn't actually done any math, that hasn't processed any logic. So errors like those where it was more so logical will happen during your runtime.
Yeah, you guys won't get any compile time errors for the most part because you only get those in casting, which is not in scope, and like Abhishek said, in logic errors. What is the difference between dog B and dog D? It seems they are both referring to a new hungry dog. Yes, so the difference between dog B and dog D is that dog D isn't a dog. The static type is hungry dog, right? So like I said in chat, The variables are kind of boxes that have labels on them that refer to what's inside of them. And so one box says dog, one box says hungry dog. Sure, they both contain hungry dogs, but the boxes are, one box is more broad in what it can contain than the other, if that helps.
So it looks like the answer to the question, why is B the Bark compiler? But just to reiterate, when we're here, we're going to look at the static type of B, right? That's going to be a dog. And once we're here in dog, we don't see bark anywhere. So we're going to return compile time error because there's no method to lock onto here. So there's nothing for us to return during compile time. But people have done a really good job in the chat of explaining that. Okay.
So if dog had a method that hungry dog didn't, and we had hungry dog D equals new hungry dog, then D would not be able to use that method in the dog class that hungry dog doesn't have. Nope, that's not true. And so the reason is because obviously hungry dog extends dog, right? So hungry dog has access to everything inside of dog, plus whatever hungry dog has for just itself. So even if hungry dog doesn't define a method, if dog has it, then we can still access it.
Yeah, so if this was like d.eat instead, this would still run the exact same way. It'd still function perfectly same. I mean, I may just missed adding an example of that, so that's my fault.
Yeah, in this case, d.eat would still return eating dog food, or d.eat with dog food in it.
So you ask a question, b.eat returns eating a lot because it checks, so there are two steps, right? During compiler time, we're gonna look at this static variable, and we're gonna lock onto this method here. And we see this method and we see, okay, I'm gonna be using this method as of right now. But if we go to runtime and we look at this dynamic type, and we find a method with the same exact signature, so public void eat, and we find that right here, we're gonna use this method instead. So at the very end, during runtime, Java will decide to use whatever in the dynamic method if it's possible.
In terms of examples where they use interfaces and implements rather than superclasses and extends, DMS classically is usually done with just superclasses, subclasses, because with interfaces, obviously there are different, you can have multiple interfaces, so it gets a little weird and not necessarily things that we need to know as programmers. And so for the most part, I think you will only deal with either superclasses and subclasses or a single interface, in which case the rules are identical to what superclasses have. Wait, so what would be the point of saying a hungry dog under a static type dog? So the point of doing that is basically, you can, okay, let's say you have, there's this very specific example that comes up often, and I said this in my discussion section, which some of you might have caught at the end of yesterday during the last recession. But there's a very specific example where basically, let's say you have two variables that are both static type dog and dynamic type hungry dog, okay? And let's say that dog, the class, has a function that takes in dog and a function that takes in hungry dog. They have the same name, they just take in different parameters. Let's say the hungry dog overrides the second function. So hungry dog has the same function that takes in another hungry dog. So if you call that function, let's say bark at, on the second variable, if you call the bark at function on the second variable, at compile time, what'll happen is that it'll see, okay, both of those variables are dog variables. And so because of that, you will, what will happen is at compile time, your computer will pick the version of the function that is in the dog function and takes in a dog, right? So we lock into that function signature. Now at runtime, what's going to be funky is that the dynamic type of both those variables is hungry dog. So as a human, you logically think that you're going to move over to the version of the function that's within hungry dog and takes in a hungry dog. However, we kind of lock into whatever function signature we use at compile time. So even though the dynamic type of that parameter that we're passing in is hungry dog, we've already locked on to the function. We've already locked on to the function that takes in a dog. So unless hungry dog overrides the function with the exact same parameters, it also has to take in a dog rather than a hungry dog. We can't override it. So we're going to use the function in the superclass, even though there's technically a function that fits better in the subclass. And you can exploit this when you write code. It's not a super common case. It's kind of a bit of an edge case, but it is a common test question because it is so funky. So that's why dynamic versus static types are important. We should have had an example on that. That is our fault. I hope that's clear. It would have been clearer if we had a slide on it.
It's like, Anjali, I do have a slide on it if you want me to throw
Oh,
it up
yeah,
really
sure.
quickly.
If you can pop it up.
I've got this exact example really quickly.
In case
I
anyone
wish I
wants to
could
see it and not
screen
just
share.
hear
let
me
me
try
share.
to explain code.
Yeah. It's like, it's really hard to see, but like once you see the different methods in runtime, it'll make a lot more sense why
We'll pop it up
we're
real quick.
explaining such a meticulous topic. It sounds like we're just like
Parameter names
explaining
don't
something
count.
that's like,
Yeah, sorry.
Yeah.
Real quick to answer a question in the chat. Parameter names don't matter. Parameter types matter. And yeah, I think that's it. I don't think the order of I think the order of parameters might matter actually, regardless. That's not something you need to test it on.
so we've got a zombie class and we've got a fast zombie class. Each of these has two byte classes or byte parameters or byte methods, sorry, that take in different parameters. So say the zombie class has like a byte method that takes in a zombie and a byte method that takes in a fast zombie. The fast zombie class also has a byte method that takes in a zombie and a byte method that takes in a fast zombie. So like,
I was gonna say yomp. And
yeah, I don't know who said that or if you meant to say that, but yes. The first one does say yomp. We might be getting ahead of ourselves. But like during static, sorry, that was, during like compile time, the static types are zombie for both, let's say Greg and Witch, right? But then during runtime, let's call these the dynamic types, right? The dynamic types are different, okay? So during compile time, right, this is static type, so Witch is static type zombie, Greg is static type zombie, right? So then we lock onto this function here, okay? Same thing, right? Witch is static type zombie. Greg is, or sorry, Witch is also static type zombie, right? So the compiler actually locks onto this function here, okay? Does that make sense? And then like during runtime, right? Now we actually consider the dynamic types of the method callers, right? So like, what do y'all think these two things print, just based off what we know of DNS? Yeah, it is from the HK review session side. Sorry, I wrote this slide for the session last week, or this. Yomp for both, yeah, okay. Why yomp for both? So for those of y'all that actually went to HKN, you know, but for those of y'all like confused on why we have this methodology, what ends up happening is during runtime, we consider dynamic types, right? But we don't consider dynamic types of arguments, okay? We only consider dynamic types of like instances or like callers, we like to call them. So which, in this case, is dynamic type fast zombie, right? Sorry for the messy handwriting. I'm doing this on the fly, right? Okay. So we look inside the fast zombie class, right? And then we see like, we look for a method that matches the signature of the locked method exactly, right? So in this case, the signature is public void by zombie Z, okay? So we're looking for a public void by zombie Z inside the fast zombie class, right? Which is this one, right? So that's, we print like yomp here, right? And then in this case, right? The very common mistake on the exam is to say, well, which is dynamic type fast zombie? So they will print, you know, or y'all will print, I don't know, the student will print you're fast, I'm faster a lot of times, which is this method, right? But that's incorrect because this method signature doesn't match this locked on compiler function exactly. Does that make, I don't know, Anjali, can you explain it better? I'm sorry.
You're totally right. The only thing I'd add is that it doesn't have to look for the entire function signature. It only cares about the name and the parameters. I made that mistake when I first started looking at this stuff, but it doesn't actually care about what the return type is, even though you might get an error if the return type changes because of the fact that you are probably assigning it to something. Yeah. Yeah, it's a little weird. It's a weird, funky brain thing, especially this is a 2-class case. I don't know if you guys have done discussion yet, but there is a 3-class version of this too, where there's ABC. That's also very tricky. It adds a little more complexity. So if you're still struggling with this, I highly recommend looking over those problems on the discussion worksheets because they are annoying, but they are useful. Okay, any more questions on this stuff? And exercise and suffering. I mean, for you and me both. The discussion this week, the second question on the normal discussion is probably my least favorite problem in the entirety of this class. It is 3 classes that are named A, B, and C, and it's an exercise in dynamic method selection. And the names are just really confusing. But it's about as hard as it gets, so. No, animal and cat comes, I believe. That's problem 1, which is also good. Problem 2 is annoying. There's also a little bit of casting on that worksheet, though. I'll warn you in advance. The names we will try not to make the names confusing on the exam. We don't try to trick you as much as 61A tends to. Not as a diss to 61A, it's just that that's part of their scope thing. We don't care as much about scope in 61B, so we give things reasonable names. So we treat the parameter as part of signature. Yes, you don't care about the dynamic type of the parameter at all. Which dot byte which will return yomp because during compilation which is considered static. Which dot byte which
I'm
will
gonna throw it
return,
up again.
yes,
I'm gonna throw it.
it'll return yomp because the static type of which is zombie, right? So at first we pick zombie and we find the function that takes in a zombie, and then at runtime, the dynamic type of what we are calling byte on, which is the first which, is actually fast zombie. So we check fast zombie to make sure there isn't a function there that has the same function signature, which there is. So we move over there and we return yomp. Yes, I hope that makes sense. Will Greg run give a compile time error? Greg.run will give a compile time error. And in fact, which.run, I believe, will also give a compile time error because the run function does not exist in the zombie class at all. This is where casting becomes useful, but that's not relevant right now. It doesn't dynamically determine the parameter type. Yeah, so basically the parameter, okay, think of it this way. The parameter isn't like unpackaged. You don't open the box on the parameter until you enter the function, right? You don't check what's in the parameter. You don't check anything about the parameter except the label on the box until you're already in the middle of executing the function. Because of that, we don't look at it to pick which function we use. We just look at the box itself and we say, okay, this box goes into this category, so we're going to use this function, and then in the function we take what's in the box outside and actually, do stuff with it. I like the box analogy if you can't tell. I think it's helpful. Whatever works for you. Okay, any other questions? We'll stick around for like 4 more minutes. What about which.run?
Any of that also give her error?
Yes. It'll also give a compile time error because which has static type, zombie. So at compile time, we check the zombie class. There is no run function. So we error immediately. We never even get the chance to check the dynamic type. And like I said before, you can get around this by casting and basically telling the computer, pretend that the witch is a fast zombie during compile time. I promise that's what's in the box. If there was a run method in zombie, then yes, it would return skirt because it would pick the version that is in the dynamic type during runtime. Yes. Any final questions? If not, I will stop the recording.